It was an ordinary summer afternoon in 1950. At a laboratory nestled among the mountains of New Mexico, where men who had spent years reshaping the world sat down together for lunch, and one of them asked a question so simple, so quietly devastating, that it has never truly stopped echoing. Enrico Fermi, one of the most brilliant minds the 20th century had ever produced, set down his fork, looked at the faces of his colleagues, and asked, in his careful, accented English, "Where is everybody?" It was not a dramatic declaration, it was barely more than a murmur over a cafeteria meal, and yet those 3 words contained within them a paradox so vast, so strange, so deeply unsettling and beautiful all at once, that physicists and philosophers and dreamers have been sitting with it ever since, like a stone dropped into still water, the ripples still moving outward, still reaching new shores. To understand why the question matters, you have to first let yourself feel the scale of what surrounds you tonight, as you lie here in the quiet dark, above you, beyond the ceiling, beyond the atmosphere, beyond the soft blue veil of sky that you have known your entire life. There are more stars in the observable universe than there are grains of sand on every beach and desert on Earth, 400 billion stars in our galaxy alone, and our galaxy, the Milky Way, is only one of perhaps 2 trillion galaxies drifting through the deep, each one a vast country of light and gravity and time. Among those 400 billion stars in just our galaxy, astronomers now know that planets are not rare, they are extraordinarily common, orbiting nearly every star like quiet, faithful companions, and among those planets, a significant portion sit within the gentle zone where liquid water can exist, where chemistry can grow complex, where, in theory, life might find its first tentative foothold. The numbers, when you let them wash over you slowly, suggest that we should not be alone, not even close to alone. The mathematics point toward a cosmos brimming, overflowing, crowded with the possibility of minds looking up at their own night skies and wondering. In 1961, an astronomer named Frank Drake sat down and tried to turn that intuition into something you could hold, something you could reason with. He wrote out an equation, a series of gentle multiplications, each one asking a different question about how common life and intelligence and civilization might be. How many stars form each year? How many have planets? How many of those planets could support life? How many actually develop it? How many of those rise to intelligence? How many reach out across the silence with signals? And how long do those civilizations survive? The Drake equation does not give you a single clean answer. It gives you a range, a spectrum of possibilities stretching from dozens of civilizations sharing our galaxy right now, to millions, to just us, floating alone in all this darkness. And here, very gently, is where the silence becomes strange. Because if the numbers suggest that life should be common, if intelligence should have arisen again and again across billions of years of cosmic history, then where are the signals, where are the transmissions, the megastructures, the quiet hum of other minds reaching across the void? We have been listening, carefully, patiently, with increasingly sensitive instruments pointed at the sky. The search for extraterrestrial intelligence, SETI, has been scanning the frequencies since the early 1960s, enormous radio telescopes tilting their vast white faces toward the stars night after night, collecting data, analyzing waveforms, waiting for something that does not sound like nature, something that sounds like intention. And the answer, after all this time, has been silence, a deep, unbroken, extraordinary silence that seems almost louder than sound. This is the paradox Fermi's question revealed. The universe is old enough, large enough, and apparently hospitable enough that we should have heard something by now, and we have not.
As you relax now, letting your breathing slow and your body sink a little heavier into where you rest, let that silence wash over you like something vast and dark and full of stars, not frightening, just enormous, just wide, just ancient and still and waiting. We are going to spend this evening exploring that silence together. We are going to trace the mathematics of how many civilizations might exist. We are going to listen with the great radio ears of humanity to what the cosmos has and hasn't said. We are going to sit with some of the most beautiful and terrifying ideas our species has ever conceived about why we might be alone. And in the end, we will rest with the question itself, which is perhaps the most honest place any of us can be. For now, let the question simply breathe inside you. Where is everybody? In the early 1960s, a young astronomer named Frank Drake stood at a blackboard at the National Radio Astronomy Observatory in Green Bank, West Virginia, and wrote down an equation. It was not a particularly complicated equation, as these things go. But it was an equation of extraordinary ambition, because what it attempted to calculate was nothing less than the number of intelligent civilizations in our galaxy that we might be able to communicate with right now, at this very moment. Drake had called together a small conference, the first serious scientific gathering ever dedicated to the search for extraterrestrial intelligence. And rather than beginning with speculation or philosophy, he wanted to organize the problem, to break the vast unknowable question down into smaller questions that might be answerable, one by one, the way you might approach a very dark room by finding just one light switch at a time. His equation began with our star, the rate at which new stars are formed in the Milky Way each year. This is something astronomers can actually measure with some confidence. The Milky Way births approximately 1 to 3 new stars per year. A gentle, steady heartbeat of creation, year after year, across billions of years. From there, Drake moved to the fraction of those stars that have planets. When he wrote his equation in 1961, this number was almost entirely unknown. Astronomers suspected planets were common, but they had no proof. Today, thanks to Kepler and its successors, we know this number is very close to 1. Nearly every star has planets. It is one of the most reassuring findings in modern astronomy. The universe is generous with worlds. Then comes the average number of planets per star that might support life, that exist within the habitable zone, with the right conditions, with liquid water perhaps, with chemistry rich enough for biological processes. Current estimates suggest this number might be somewhere between 1 and 5 for many star systems. Not every system, but many, possibly most. And here the equation begins its journey into deeper uncertainty, like a path that leads from sunlit meadow into thickening forest. The next variable is the fraction of those potentially habitable planets on which life actually arises. And this is where the equation becomes both thrilling and humbling. On Earth, life arose remarkably quickly. Within a few 100 million years of our planet's formation, when the surface had cooled enough to hold liquid water, life was already here. Already stirring in the shallow seas. Already doing the ancient chemical work of metabolism and reproduction. Some scientists read this as evidence that life arises easily, that it is almost inevitable wherever conditions allow, that the universe is in some sense patient and persistent about creating it. Others are less certain. They point out that we have exactly one data point ourselves, and drawing statistical conclusions from a single example is always dangerous ground. Perhaps life on Earth arose through a sequence of chemical events so extraordinarily unlikely that it has happened only once in the entire observable universe, and we are that once. That range of uncertainty, from life is everywhere to we are the only life, lies inside a single fraction in Frank Drake's equation. And it is a fraction we do not yet know. Let that uncertainty rest in you gently, not as anxiety, but as openness, as a door not yet opened. Moving forward through the equation, we come to the fraction of life-bearing worlds that develop intelligence. Life on Earth existed for roughly 3.5 billion years before anything appeared that we would recognize as intelligent in the way we use the word. Single-celled organisms dominated the planet for billions of years, quietly, efficiently, without any apparent urgency toward complexity. The step from simple life to complex, multicellular life appears to have happened only once in Earth's history, in what biologists call the Cambrian explosion, around 540 million years ago. And intelligence, self-aware problem-solving intelligence, appears to have emerged perhaps only once as well, in our own lineage. Some biologists argue that intelligence is not an inevitable destination of evolution, but rather a peculiar accident, a path only one branch of one tree on one planet happened to stumble down. Others argue that given enough time and enough pressure, something that thinks and adapts and builds will always eventually appear. The equation holds both possibilities without choosing. Next comes the fraction of intelligent species that develop technology capable of detectable communication, radio waves, laser signals, something that bleeds out into space and announces their presence to the universe. On Earth, we went from early Homo sapiens to radio telescopes in less than 300,000 years. Cosmically speaking, that is essentially instantaneous. But perhaps not every intelligent species chooses technology, or survives long enough to develop it, or develops it in forms we would recognize. And finally, the most haunting variable of all. The average length of time a civilization continues to transmit detectable signals into space. Or more broadly, the average lifespan of a technological civilization before it falls silent. This variable carries the weight of everything we fear about ourselves. A civilization that destroys itself through war, or environmental collapse, or the inevitable drift of its own entropy, might broadcast for only a few centuries before going dark. A civilization that endures, that solves its existential problems and reaches some kind of stable, star-spanning maturity, might broadcast for millions or billions of years. When optimistic values are plugged into the Drake equation, when you assume life arises readily, intelligence follows, and civilizations tend to endure, the equation spits out a number in the millions. Millions of communicating civilizations in the Milky Way alone, right now, at this moment. If that is true, the nearest one might be just a few hundred light-years away, a cosmic whisper's distance. When pessimistic values are used, the equation collapses. It can produce a number less than 1, suggesting that we might be the only technological civilization our galaxy has ever produced. The range is staggering, from 1 to millions, and within that range lives the entire mystery. What is beautiful about the Drake equation is not that it gives us an answer. It doesn't. It was never meant to. What it gives us is a map of our ignorance, a careful diagram of exactly what we do not know. Each variable is a door, and behind each door is a research program, a telescope, a life's work. As your breathing deepens and your body continues to let go, imagine those millions of possible civilizations scattered across the soft darkness of the Milky Way like distant campfires, each one a story, each one a world of some kind of mind looking up at its own night sky, wondering the same questions we wonder. And yet, for all the mathematical promise of Drake's equation, for all the optimistic estimates of billions of habitable worlds and easy abiogenesis, when we actually point our instruments at the sky and listen, we hear nothing. The silence is real, and it is deep. For more than 60 years, human beings have been listening. It began in earnest in 1960, when Frank Drake himself pointed an 85-foot radio telescope at two nearby sun-like stars, Tau Ceti and Epsilon Eridani, and listened for 2 months for any signal that might betray the presence of another civilization. He called the project Ozma, after the Princess of Ella Frank Baum's distant and mysterious land of Oz. He heard nothing that could not be explained by natural sources. But the act itself was profound. For the first time in human history, we were not just wondering whether we were alone, we were asking. The search for extraterrestrial intelligence, SETI, grew from that single telescope pointed at 2 stars into a decades-long international effort of extraordinary patience and dedication. Researchers at observatories across the world developed increasingly sensitive receivers, scanning wider and wider ranges of radio frequency, listening at wavelengths that physicists theorized an alien civilization might choose to broadcast on. The hydrogen line, at 1420 MHz, was considered especially promising, a frequency tied to the most abundant element in the universe, a natural meeting point that any technologically sophisticated species might recognize as a likely channel for communication. And so they listened, year after year, decade after decade, scanning the sky with instruments of growing sophistication, cataloging millions of radio signals, filtering out the static of human technology and the known emissions of natural astronomical objects, searching through the remainder for something that carried the unmistakable signature of intelligence, a pattern, a repetition, a structure that nature alone could not explain. And for 60 years and more, they found nothing. Almost nothing. On the night of August 15, 1977, a volunteer researcher named Jerry Yemen was reviewing data printouts from the Big Ear radio telescope at Ohio State University. The telescope had been scanning the sky automatically, and Yemen was going through the output by hand, column by column, the way researchers did in those days before computers could do it for them. And then he saw it. A signal so strong, so precisely aligned with the hydrogen line frequency, so unlike any known natural source, that Yemen circled it in red ink and wrote in the margin the single word that has echoed through the decades ever since. Wow! The wow signal lasted exactly 72 seconds, the length of time a point in the sky would remain in the telescope's beam as Earth rotated. It was never detected again, despite dozens of follow-up observations of the same patch of sky, despite increasingly powerful instruments trained at precisely that location for years afterward. It came, it was heard, and it was gone, leaving only a red circle on a strip of paper, a ghost of something that may or may not have been what it seemed. Most astronomers today believe the wow signal was probably a natural phenomenon, perhaps a burst from a hydrogen cloud in the galaxy, perhaps something else entirely. But no one has definitively explained it. And in the absence of an explanation, it remains a small, persistent light in the long darkness of the great silence, the one moment when the universe seemed, just for a second, to clear its throat. In the decades since, the search has expanded enormously. The SETI Institute was founded in 1984 and has operated continuously, developing new algorithms, new telescopes, new approaches. The Allen Telescope Array in Northern California, partially funded by Microsoft co-founder Paul Allen, was designed specifically for SETI research, its 42 dishes working together in a kind of patient, mechanical choir. And then in 2015, the Russian-Israeli entrepreneur Yuri Milner announced the Breakthrough Listen initiative, the most comprehensive and well-funded SETI program in history. $100 million over 10 years, with access to the world's largest radio telescopes, scanning 1 million nearby stars and 100 nearby galaxies across a wide range of frequencies. The instruments are sensitive enough to detect the equivalent of an airport radar signal from any star within a distance of 1,000 light-years. It has been listening since 2016. And the answer, as of this moment, remains the same. Silence. Not ominous, active silence, not the silence of something hiding, or at least not provably so. Just silence, the neutral, impassive silence of a universe that either has nothing to say to us, or is saying things in ways we haven't yet learned to hear. It is worth pausing here to appreciate the depth and breadth of what we have actually searched, because the numbers are both impressive and humbling in equal measure. We have examined tens of thousands of stars in detail, and millions more in survey form. We have scanned radio frequencies across a vast range of possible communication bands. We have looked, more recently, for laser pulses and other optical signals. We have cataloged the spectra of thousands of distant stars looking for the chemical signatures of technology. And in all of that searching, in all of those years and all of those instruments and all of that patient, dedicated, professionally unrewarded listening, we have not found a single confirmed signal of extraterrestrial origin. This is what scientists call the Great Silence, or sometimes, in honor of the man who first articulated the paradox, the Fermi silence. Let it settle around you now like the darkness itself, not frightening, just very, very wide, a silence as old as the universe, older, perhaps, than stars. The question then becomes not just why haven't we found anyone, but something deeper and stranger, given the mathematical expectation that the galaxy should be full of civilizations, why is the silence so complete? Why not even a hint? Why not a leakage signal, a beacon, an artifact, a trace? Something must explain it. And the explanations people have proposed are among the most fascinating, and occasionally most disturbing, ideas in all of science. In 1998, an economist named Robin Hanson published a paper with a title that has haunted thinking people ever since. The Great Filter, Are We Almost Past It? Hanson's reasoning was elegant and chilling. He started from the same place Fermi had at the observation that the universe is old and large and seemingly full of potential, and yet silent. And he drew from that silence a simple but devastating conclusion. Somewhere between dead matter and galaxy-spanning civilization, something stops the process. Something filters it out. There is a step, or perhaps several steps, along the path from raw chemistry to spacefaring intelligence that almost nothing survives. Something extraordinarily difficult, extraordinarily unlikely, extraordinarily lethal, something that explains why, despite all the promise of the Drake equation, the galaxy appears empty. Hanson called this the Great Filter. And then he posed the question that keeps cosmologists awake at night. Have we already passed through the Great Filter? Or does it lie ahead of us? Think about what lies behind us, the series of transitions that had to occur to produce a being capable of reading Hanson's paper. First, the origin of life itself, abiogenesis, the spark by which dead chemistry becomes living chemistry. This may be extraordinarily rare. Despite decades of laboratory experiments and theoretical modeling, we still do not fully understand how the first self-replicating molecules arose from a primordial soup of amino acids and minerals in ancient oceans. If this step is vanishingly unlikely, if it requires a combination of conditions so specific that it happens perhaps once in a billion galaxy years, then this might be the Great Filter, and we are on the far side of it. Or consider the emergence of the eukaryotic cell, the complex cell with a nucleus and organelles that is the building block of all complex life on Earth. For the first 2 billion years of Earth's history, life consisted entirely of simple prokaryotic cells, bacteria and archaea, single membrane bags of chemistry. And then, perhaps 2 billion years ago, something happened. One cell absorbed another and instead of digesting it, kept it. This endosymbiotic event, the merger of two independent organisms into a single, more complex one, may have happened exactly once in Earth's history. All complex life on Earth traces back to that one unlikely marriage. If that step is the Great Filter, then simple microbial life might be common in the universe, but complex life might be extraordinarily rare. Or the step might be multicellularity itself, or sexual reproduction, or the development of a nervous system, or the particular cascade of evolutionary pressures that happen to produce a primate with hands dexterous enough to make tools and a brain complex enough to teach the making of tools to others. Each of these steps, considered individually, seems almost miraculous. And if any one of them represents the Great Filter, then it lies behind us, and the news is actually good, in a cold and lonely way. It means we are perhaps the first, or one of the first, but we have survived the hardest part. The galaxy is ours to explore, and the future is very, very long. But here is the terrifying possibility that Hanson raised and that has not been shaken since. What if the Great Filter lies ahead? What if life is actually quite common? What if simple cells arise readily? What if complex cells form? What if multicellular life and intelligence and technology all emerge with reasonable frequency across the galaxy? And what if there is something ahead of where we currently stand on the developmental ladder that almost nothing survives? This could be a technological threshold. The transition to industrial civilization consistently destabilizes the planetary ecology in ways no civilization manages to survive. Or it might be an even harder threshold. The development of weapons of civilizational destruction, biological or nuclear or something we haven't yet imagined, that every civilization eventually uses on itself before it can cross the gulf between stars. Or perhaps it is something we cannot even conceive of yet, a challenge that only reveals itself at a certain level of technological advancement, the way the dangers of nuclear fission were invisible to beings that hadn't yet split the atom. If the great filter lies ahead, then the silence of the cosmos is not a reassurance, it is a warning. We are approaching something that has ended every civilization that came before us. And this brings us to what is perhaps the most unsettling implication in all of science, the thing that makes exobiologists lie awake staring at their ceilings. If we were to find life on Mars, not ancient fossils of life, but actual living organisms, microbial life in the deep regolith or under the polar ice, it would be, on its surface, the most thrilling discovery in the history of science. The confirmation that life arose not once but twice, independently, in the same solar system, within a few 100 million years of each other, implying that life arises easily, that the universe is teeming with it. And it would also be, in the coldest possible reading, potentially the worst news our species has ever received. Because if life is common, if it arises wherever conditions allow, then the great filter probably does not lie in abiogenesis or early cellular evolution. It probably lies ahead of us, in something we have not yet faced, something that apparently no civilization has survived. The more life we find scattered across the cosmos, the darker the road in front of us might be. Rest with that for a moment, not as fear, but as weight, as the gravity of the question. Not all explanations for the great silence are as inward-looking as the great filter. Some are stranger. Some reach outward, into the darkness between the stars, and imagine reasons why intelligent civilizations might exist and yet be deliberately, terrifyingly quiet. The most chilling of these comes not from a scientist, but from a novelist. Liu Cixin is one of China's greatest science fiction writers, and in his trilogy beginning with the three-body problem, he proposed what he called the dark forest theory of the universe. It is a solution to the Fermi Paradox that is, in its terrible logic, almost impossible to refute. Imagine the galaxy as a dark forest. In this forest, there are many hunters, many civilizations, many forms of intelligence moving through the trees. Each hunter knows that other hunters exist. And each hunter knows something else, something fundamental and inescapable. Any civilization that reveals its location risks destruction. The reasoning unfolds with the cold precision of a game theory problem. Resources in the universe are finite. Any sufficiently advanced civilization requires resources. Two civilizations that encounter each other cannot fully trust each other, because trust requires communication across vast distances of space and time, and miscommunication or deception can have civilization-ending consequences. And crucially, technological progress is unpredictable. A civilization that seems less advanced today might outstrip you within 1,000 years, and 1,000 years is nothing in cosmological time. Therefore, the rational strategy for any civilization that discovers another is to destroy it before it can grow into a threat. Not out of malice, necessarily, but out of cold strategic calculation, the same calculation that drives arms races and preemptive strikes throughout human history, scaled up to the size of the galaxy. In a dark forest universe, the silence is not emptiness, it is camouflage. Every civilization that survived long enough to understand the stakes when quiet, erased its radio leakage, dimmed its planetary lights, pulled the curtain across its existence as completely as possible. And any civilization that was loud, that broadcast enthusiastically into the cosmos the way we did in the 20th century, either learned the lesson in time, or did not, and was silenced by something else. The dark forest theory is not accepted science, it is speculation, a thought experiment, a philosophical provocation. But it is a provocation that some serious thinkers find disturbingly plausible. And it is worth noticing that if it were true, there would be no way to test it, because any advanced civilization operating under the dark forest principle would be, by definition, undetectable. The darkness of the forest, and the silence of the hunters within it, would look exactly like what we see. A related but different hypothesis imagines not civilizations hiding from each other, but rather civilizations proactively eliminating threats before they can mature. This is sometimes called the Berserker hypothesis, drawn from a series of science fiction novels but based on a genuinely disturbing logical possibility. Imagine an ancient civilization that, billions of years ago, built self-replicating machines, probes that could travel between stars, mine raw materials, and build copies of themselves. Such machines, given enough time, could spread across the entire galaxy in perhaps 10 to 100 million years, cosmic minutes, in the life of the universe. Now imagine that this ancient civilization, for whatever reason, programmed those machines to identify and destroy any technological civilization they encountered, perhaps out of fear, perhaps out of resource competition, perhaps out of some cold ideological directive we cannot imagine. These machines, these berserkers, would by now be everywhere, waiting in the darkness between stars, monitoring for the telltale electromagnetic signatures of radio and industry and light pollution, and silencing anything that made itself known. We have been broadcasting radio waves into space for about 100 years. Our signal bubble has expanded 100 light-years in all directions. If there are berserkers within 100 light-years of Earth, we have already announced ourselves. Allow yourself to breathe through that idea, feel how it passes through you, a cold thing, like deep space wind, and then let it go into the dark where it lives. There is a gentler, and in some ways more unsettling, hypothesis called the planetarium hypothesis, proposed by Stephen Webb in his book on Fermi solutions. It suggests that what we perceive as the universe, with its billions of galaxies and its vast empty silences, may not be what is actually there. Perhaps an advanced civilization has the capability to simulate our observations, to construct around us a virtual universe of perfect fidelity, designed to make us believe we are alone, perhaps to protect us from a truth we are not ready for, perhaps for reasons utterly beyond our comprehension. This shades into the simulation argument, most famously articulated by philosopher Nick Bostrom, which suggests that any civilization sufficiently advanced to run detailed simulations of conscious experience would likely run many such simulations, and statistically speaking, any particular conscious being is far more likely to exist inside a simulation than outside one. If we live inside a simulation, the Fermi Paradox dissolves. There are no other civilizations because no other civilizations were coded into this particular simulation. We are alone because whoever runs this particular program chose to set the starting parameters that way. These ideas are not comfortable, but they are also, in their way, magnificent. They are evidence of how far the human mind can reach, how willing we are to follow a logical thread into the strangest possible places in our attempt to understand why we seem to be alone. There are gentler hypotheses, too, ones that imagine not danger or deception but simply a universe that operates on different terms than we expect. The zoo hypothesis was proposed by John Ball in 1973 and has been a recurring presence in SETI discussions ever since. It suggests that Earth is, in some sense, set aside, deliberately left undisturbed by more advanced civilizations the way we set aside nature reserves, or the way modern anthropologists maintain protocols of minimal contact with isolated human tribes. Perhaps there is a galactic community of civilizations, communicating and trading and exploring among themselves, and they have collectively agreed, for whatever ethical or scientific or practical reason, to leave certain planets, including ours, alone, to develop without interference. We do not hear their signals because those signals are not directed toward us. We do not see their ships because they choose not to show themselves. In this scenario, the silence is not emptiness, it is respect, or perhaps something more paternalistic, the way an adult might refrain from answering a question a child is not yet ready to understand. There is something almost comforting about the zoo hypothesis, and also something faintly humbling. We are not alone, we are observed, we are, in a sense, cared for, but we are also, in a sense, managed, kept in our enclosure while the rest of the universe goes about its business beyond our view. A related concept imagines not a coordinated interdict but simply the sheer impracticality of contact. The galaxy is very large and the speed of light is an absolute limit that even the most advanced civilization cannot escape. A signal sent from a star 1,000 light-years away takes 1,000 years to arrive. And a reply takes another 1,000. Conversations across the galaxy would take generations, or civilizational lifetimes. Perhaps contact simply hasn't happened because the logistics are prohibitive even for beings far more patient than we are. This is sometimes called the contact threshold hypothesis, the idea that interstellar communication requires a level of temporal patience and organizational stability that most civilizations, including perhaps our own, simply haven't achieved. There is another possibility that deserves time and space in this quiet hour, the idea that civilizations do not stay the way we imagine them, that intelligence, given enough time and enough technology, transforms into something unrecognizable. Imagine a civilization 1,000,000 years older than ours. They have had 1,000,000 years to develop their science, their technology, their understanding of physics. What would they be? It is almost impossible to say, because the trajectory of our own development over just the last few centuries has produced changes that would have been incomprehensible to our ancestors. Some theorists suggest that sufficiently advanced civilizations would naturally migrate away from biological, physical existence altogether, that they would upload their minds into computational substrates, or merge into collective intelligences operating at quantum levels of complexity, or find modes of existence so far removed from what we recognize as life that they would be, quite literally, invisible to instruments designed to detect radio broadcasting bipeds on rocky planets. This is sometimes called the transcension hypothesis, the idea that the arrow of technological progress does not point outward, into the physical universe, into space and colonization, but inward, into ever smaller, ever more efficient, ever more private spaces of computation and consciousness. A transcended civilization might be extraordinarily advanced and extraordinarily quiet simultaneously, not because they are hiding, but because they have simply moved beyond the stage where broadcasting radio waves seems interesting or relevant. And then there are what some researchers call hermit civilizations, civilizations that have, for their own reasons, chosen isolation. Perhaps they are contemplative, turned inward toward art or philosophy or forms of experience that do not require the resources of other stars? Perhaps they have been burned by contact with others, and retreat is their rational response. Perhaps they simply find the cosmos less interesting than what they have built within their own small corner of it. In a universe where even 1 in 1,000,000 civilizations is outwardly expansive and communicative, the math of the Drake equation still suggests we should hear something. But if the vast majority of civilizations are hermits, transcended, introverted, or simply uninterested in the radio frequencies of a younger species, then the silence becomes more understandable. The universe may be full of minds looking inward while we alone, for now, look out. Beyond the question of radio signals, there is a growing realization among scientists that the search for extraterrestrial intelligence, or simply for life of any kind, need not be limited to listening for deliberate communications. A civilization capable of technology leaves marks on its environment that might be visible across interstellar distances, whether it intends them to be or not. And the search for these marks, these techno-signatures, is becoming one of the most exciting frontiers in modern astronomy. Consider the Dyson sphere. Freeman Dyson, one of the most original minds in 20th century physics, proposed in 1960 that a sufficiently advanced civilization would eventually require more energy than its home planet could provide. The logical solution would be to capture the entire output of its star, to surround that star with a shell or a swarm of solar collectors, harvesting every photon. A complete Dyson sphere would make the star invisible in optical wavelengths, but the waste heat of all that collected energy would have to go somewhere, and it would radiate in the infrared. So a star surrounded by a Dyson sphere would appear dark in visible light but bright in infrared, a peculiar signature that would stand out against the stellar background like a fingerprint. Astronomers have actually searched for such objects, cataloging millions of stars looking for the anomalous infrared excess that might betray the presence of a stellar megastructure. The most tantalizing candidate, discovered in 2015, is a star called KIC 846-2852, nicknamed Tabby's star after astronomer Tabitha Boyajian, who led its study. This star dims and brightens in patterns so irregular and so extreme that natural explanations have struggled to account for them fully. For a brief, electric moment, a Dyson swarm was seriously considered as a candidate explanation. Most astronomers now believe Tabby's star's behavior is more likely explained by clouds of circumstellar dust. But the fact that the hypothesis could be seriously entertained, that our instruments are now sensitive enough to make such searches plausible, marks a turning point in the long history of this question. The James Webb Space Telescope, launched in December 2021 and now operating at a distance of 1 million miles from Earth, carries instruments of extraordinary sensitivity capable of analyzing the atmospheres of distant exoplanets. When the light of a star passes through the atmosphere of an orbiting planet, it carries within it the spectral fingerprints of the gases it has traveled through. Oxygen, methane, carbon dioxide, water vapor each leaves its mark in the spectrum. And some combinations of gases, like the simultaneous presence of oxygen and methane in a planet's atmosphere, would almost certainly require a biological source to maintain, because these gases react with each other and would quickly disappear in the absence of something continuously producing them. Webb has already detected carbon dioxide in the atmosphere of exoplanets, water vapor, sulfur dioxide. These are not biosignatures, not yet, not in the planets so far examined, but the capability is there, and growing. Within the next decade, it is possible, not certain, but genuinely possible, that Webb or its successors will find a planetary atmosphere whose chemistry can only be explained by life. Beyond radio and infrared, researchers have proposed searches for lasered communication, tight, powerful beams of light carrying information across interstellar distances with extraordinary efficiency. A laser communication signal would be nearly impossible to distinguish from a natural source unless you happen to be in exactly the right direction at exactly the right moment, but for a civilization that already knows where another civilization lives, it would be the ideal private channel. The Breakthrough Listen project has expanded its search beyond radio to include optical frequencies, scanning for laser pulses that might betray such a directed communication network. They have not found one, but they look. There is also growing interest in the possibility that a sufficiently advanced civilization might manipulate gravity using masses to create detectable gravitational signatures, or engineering objects that would subtly.
The planetarium hypothesis offers yet another kind of darkness, a more interior darkness. It was proposed by Stephen Webb as a variation on the zoo hypothesis, the idea that advanced civilizations might be deliberately withholding contact, observing us from a careful distance the way we might observe a creature in a wilderness preserve. But the planetarium hypothesis goes further. It suggests that what we perceive as the empty universe, the vast, signal-silent sky above our radio observatories, the desolate alien landscapes we can only imagine beyond the reach of our probes, might itself be a constructed illusion, a simulation, or a perceptual filter, designed to make the cosmos appear uninhabited to civilizations that have not yet reached some threshold of development or wisdom. In this telling, the silence is not real. It is a gift, or a test, or a form of protection, and the universe we see when we press our eyes to telescopes and our ears to radio receivers is not the universe as it truly is, but a carefully maintained stage set, patient and beautiful and deliberately incomplete. And somewhere beyond the painted backdrop of the night sky, the actual cosmos is humming with life and light and signal, waiting for us to become something worthy of witnessing it. This shades gently into the simulation argument itself, the philosophical proposition, taken seriously by a surprising number of physicists and philosophers, that our entire experienced reality might be a computation running on some substrate we cannot access or even imagine. If civilizations tend to create simulations of the universes that preceded them, and if those simulations themselves create further simulations, then by sheer weight of probability, we are almost certainly living inside one rather than standing in the original. And in that case the Fermi Paradox dissolves entirely, because our universe contains exactly as many civilizations as whoever is running it has chosen to include, which, for reasons of their own, appears to be one. There is a quietness in that thought that goes all the way down, the quietness of a snow globe, self-contained, complete, perfectly arranged, all its weather and all its seasons unfolding in exactly the way that some patient hand intended. And so we have wandered through the dark forest together, past Liu Cixin's silent hunters and their cold arithmetic of survival, past the ancient berserker machines drifting on their eternal patrols, past the painted sky of the planetarium and the recursive depths of the simulation argument, and what we find, at the end of all these corridors, is that the great silence admits of many explanations, and that each one, in its own way, says something profound about the great filter that may lie behind us or before us, the possibility that something in the long journey from chemistry to consciousness to cosmos-spanning civilization is vanishingly rare or catastrophically difficult, and that humanity, in its brief and improbable flourishing, may be navigating that filter even now, in the decisions we make and the technologies we build and the kind of future we choose to reach toward. The cosmic loneliness of the Fermi Paradox is not only a scientific problem, it is a mirror held up to the human condition, a reminder that to be a mind in this universe is to be, as far as we can tell, extraordinarily precious and extraordinarily exposed, and that the searching itself, the building of radio telescopes and the writing of equations and the sleepless wandering in the dark, is not merely science but something closer to a prayer, sent outward into the silence not knowing whether anything is there to receive it, but sending it anyway, because that is what it means to be the kind of creature we are. And as these thoughts grow soft at the edges and begin to lose their sharpness, as the hunters and the machines and the simulated skies dissolve gently into the warm dark behind your closing eyes, let yourself rest in the extraordinary fact that you have been here, awake in the night, holding the whole vast question of existence lightly in your mind, and let that question carry you now, weightlessly, into the deeper silence that waits just beyond the reach of all our wondering. And in that deeper silence, there is something waiting. Not a threat, not an answer, not even a question exactly, but a kind of listening, as though the universe itself has been holding very still, watching, the way you might watch a small creature that has wandered into a clearing and does not yet know it is being observed. This is, in its quiet way, one of the most extraordinary ideas ever to settle into a human mind, and tonight, as your breathing slows and the world outside grows still, we are going to let it drift through you, and not to disturb your rest, but to deepen it, because sometimes the grandest mysteries are the ones that relax us most completely, reminding us how small and held and wonderfully insignificant we truly are. Imagine a radio telescope, enormous and silver-white against a darkening sky, its great dish tilted upward like a cupped hand raised toward the stars, listening, just listening. For decades now, instruments like this one have swept the sky with patient, unwavering attention, searching for a pattern in the noise, a signal that could not have been made by a star or a cloud of gas or the ordinary machinery of the cosmos, a signal that could only mean one thing, that somewhere out there, a mind had reached across the void and called out into the dark. And the silence that has answered us is one of the most haunting things in all of science. The astronomer Enrico Fermi sat down to lunch one summer day in 1950 and asked, with characteristic simplicity, a question that has never quite been answered: if the universe is so vast, if the stars are so numerous, if life has had billions upon billions of years to arise and flourish and develop intelligence and technology, then where is everybody? The question is known now as the Fermi Paradox, and it lives at the intersection of mathematics and longing and a very particular kind of cosmic unease. Frank Drake, standing at a chalkboard in 1961, tried to give the question a shape. He arranged the unknowns into an equation: the rate of star formation, the fraction of stars with planets, the fraction of those planets that might harbor life, the fraction of that life that might become intelligent, the fraction that might reach out across space. Multiply these numbers together and you arrive, depending on your assumptions, at something between one civilization in the galaxy and millions of them. The uncertainty is so vast it can contain almost any answer, and yet the silence remains, the same silence that greets us tonight, the same silence that has always been here, underneath the noise of ordinary life, patient and absolute and somehow deeply, deeply restful. There are those who have proposed that the silence means something terrible, that somewhere between the first spark of life and the vast interstellar civilizations we imagine, there is a filter, a barrier so catastrophic that almost nothing survives it. Perhaps it lies behind us, in the extraordinary improbability of life itself, or of complex cells, or of consciousness, or perhaps, and this thought comes more quietly, more carefully, perhaps the filter lies ahead of us, perhaps. Every civilization, given enough time and enough power, finds a way to end itself. This is the great filter, and it casts a long, cold shadow across any honest reckoning with our own future. Others imagine something darker still, a cosmos not silent but deliberately quiet, a universe in which every civilization that has survived long enough has learned, through bitter experience, that to speak is to invite destruction, that the cosmos is not a community but a competition, that silence is not loneliness but camouflage. This is the dark forest theory, and it turns the night sky into something that looks, for a moment, quite different from the canopy of wonder it usually seems, though even this idea, held gently, at a distance, on the warm edge of sleep, becomes less frightening and more simply strange, one of many possible stories the universe might be telling about itself. But tonight we want to rest with a gentler possibility, one that asks not whether civilization destroys itself or hides in fear, but whether it simply goes somewhere else. Consider what it might mean to be truly, incomprehensibly old as a civilization, to have existed not for centuries or millennia but for millions of years, to have passed through every phase of technological becoming, to have mapped your own star, and then the stars around it, and then the arm of the galaxy you inhabit. What would you want, after all of that? What would you reach for, when you had already reached so far? Some who think carefully about these things have suggested that the most advanced civilizations may no longer need the physical universe at all, that they may have folded themselves inward, into computational substrates of unimaginable complexity, running their civilizations as pure information, as pure experience, as something we have no word for yet. They would be invisible to our radio telescopes, not because they are hiding, but because they have left behind the kind of existence that sends radio signals. They have transcended, quietly, into a mode of being that our instruments were never built to find, and in the deep night, lying still, there is something almost comforting about this image, the universe moving through us, civilizations blooming and folding and going somewhere quiet, like lights dimming one by one into a very peaceful dark. And then there is the zoo hypothesis, which whispers something even stranger and more intimate into the silence. What if we are not alone, not even close to alone? What if the galaxy is rich with intelligence, ancient and patient and aware? And what if that intelligence has simply chosen not to disturb us, the way a careful observer stands very still at the edge of a forest so as not to frighten the creatures within it? The zoo hypothesis suggests that Earth is a protected region, a place of observation rather than contact, that somewhere out there, behind a boundary we cannot see or measure, something is watching, not with malice, not with indifference, but perhaps with a kind of scientific reverence for what is still wild and uncontacted and free. Imagine the lone human figure standing in a field at night, head tilted back, watching the stars wheel slowly overhead, feeling small and wondering and impossibly awake in a sleeping world. From one angle, this is loneliness; from another, it is the most watched moment in the universe, held in the gaze of something patient and vast and not yet ready to speak. The hermit civilization takes this idea in a different direction, suggesting that some civilizations, reaching a certain depth of inner life, simply choose silence the way a solitary person might choose the mountains over the city, not because they fear contact, but because they have found everything they were looking for within themselves. Their silence is not emptiness but fullness, not absence but completion. and perhaps there is a lesson in that. Drifting down through the quiet, a reminder that the deepest forms of being do not always announce themselves. Our searches continue, the great dishes still tilted toward the sky, the data still flowing, waveform after waveform, mostly noise, occasionally something that makes a scientist's heart quicken for a moment before resolving into the ordinary. We look now not just for radio signals but for techno-signatures, the heat of vast engineering projects, the dimming of stars by megastructures, the chemical signatures of atmospheres reshaped by living things. We have been listening for 60 years and the silence has not broken, and yet we keep listening, because the question is too beautiful to abandon. What the Fermi Paradox means for us, in the end, may be less about fear and more about perspective. It holds up a mirror to our own brief, luminous moment, reminding us that we are young, that we are small, that the story is nowhere near finished, that our loneliness might be temporary, or illusory, or the very condition that makes this particular chapter of existence so vivid and so precious. And as that thought settles softly over you now, as the radio telescopes go on listening in the dark and the civilizations go on blooming and folding in the silence between the stars, let your own awareness grow quieter still, because what waits just beyond the edge of all this wondering is something even deeper than the cosmos itself. And perhaps that something deeper is not a signal received from across the void, but a new way of learning to look. For so long, the search for other minds in the universe was a search conducted through radio waves, through the patient turning of great metal dishes toward the sky, ears pressed to the static of the cosmos, hoping that somewhere in the white noise of creation, a deliberate pattern would emerge, a voice, shaped and intentional, rising up out of the dark like a lighthouse seen from a distant shore. And this search, this beautiful and lonely vigil, has its roots in a simple question that a physicist named Frank Drake once wrote on a blackboard in 1961. A question that became an equation, a formula for dreaming. The Drake equation, you may let that phrase rest softly in your mind without needing to calculate anything at all, because what it represents is less a mathematics and more a meditation. It asks us to consider how many stars form each year in our galaxy, how many of those stars hold planets, how many of those planets could sustain life, how many actually develop it, how many develop minds that reach outward, that build transmitters, that wonder, and then, with the quietest gravity, it asks how long such civilizations tend to survive. That final variable is the one that haunts all the others, because if civilizations are brief, if intelligence is fragile and the window of transmission is narrow, then even a galaxy teeming with life might be overwhelmingly, achingly silent. And silent it has been. This is what astronomers call the Great Silence, decades of listening, thousands of frequencies scanned, millions of star systems considered, and nothing that speaks back with certainty. The void does not answer. It only deepens. Proposed explanations for this silence drift through the scientific imagination like slow nebulae. One of them, the Great Filter, suggests that somewhere along the long corridor between simple chemistry and starfaring civilization, there is a barrier so difficult to cross that almost nothing makes it through. The filter might lie behind us, perhaps life itself is the miracle, or perhaps consciousness is the improbable threshold, already cleared. Or the filter might lie ahead of us, waiting somewhere in our own future like a shadow we cannot yet see. And when you hold that possibility gently, without fear, just as a thought, it lends a certain tender urgency to this pale blue moment we inhabit together. There is another theory, darker in its poetry, called the Dark Forest. It imagines a universe where every civilization that achieves awareness also achieves the knowledge that resources are finite and that a stranger, once noticed, cannot be trusted. In this vision, the cosmos is not silent because it is empty, it is silent because silence is survival, every intelligence dimming its own light, pulling its signals inward, going dark deliberately, like creatures in a vast and lightless wood who know that to make a sound is to invite something unknown and unstoppable. And then there is the gentler possibility, the one that feels almost like a lullaby, the zoo hypothesis, which suggests that we are simply too young, too small, too newly arrived to be spoken to directly, that older minds, vast and patient beyond imagining, have agreed to watch, to wait, to let us find our own way through the dark before they make themselves known. In this reading, the silence is not abandonment, it is a kind of grace. But now the search is changing, and this is where your dreaming mind can follow something extraordinary, because we have begun to look for more than voices. We are learning to look for consequences, for the fingerprints that a sufficiently advanced civilization would leave not in its communications, but in the structure of the universe itself. A Dyson sphere, let that image float slowly into view, a structure so vast it encases an entire star, capturing its light, its energy, its warmth. If such a thing existed nearby, we might see a star that radiates strangely, that puts out heat in all the wrong proportions, that dims and brightens in ways no natural process quite explains. We are scanning for these anomalies now, combing the catalogues of stellar light with instruments grown patient and precise. We are also learning to read the breath of worlds. The James Webb Space Telescope, that golden mirror drifting 1.5 million kilometers from Earth, has begun to do something once thought impossible, to analyze the atmospheres of planets orbiting other suns, to detect the chemical signatures of oxygen, of methane, of molecules that life alone tends to produce. These are called biosignatures and technosignatures, and they represent a new language of discovery, not a message in a bottle but the smell of smoke from a fire burning somewhere just beyond the hill. Laser communication is another thread in this expanding search, because an advanced civilization might not broadcast on radio frequencies at all. It might pulse information through tight beams of coherent light, brief and directional and easy to miss unless you happen to be standing exactly in the right place at the right moment, and so new instruments called optical SETI detectors are being built to watch for these nanosecond flashes, these winks of structured light aimed across the years between stars. There are even those who wonder whether a sufficiently ancient civilization might leave traces in gravitational waves, those ripples in space-time produced by the most violent events in the cosmos, whether the large-scale engineering of space-time itself might one day be legible to our instruments, whether a civilization old enough might not broadcast into space at all, but into the fabric of reality. And all of this searching, all of this extraordinary creative effort to hear what the universe might be saying, circles back always to the question that lives beneath all the equations and theories and telescopes: what does it mean for us, here, now, on this small world wrapped in its thin blue breath of air? If we are alone, then consciousness itself is something the universe is doing for the very first time in this corner of space, and every thought you have ever had, every dream, every moment of love or grief or quiet wonder, is cosmically unprecedented. If we are not alone, then we belong to something larger than we can presently imagine, a community of minds scattered across the light years, each one finding its own way through the same vast dark. Either answer is astonishing, either answer is beautiful, and both of them invite you now to sink more deeply into the stillness of this moment, because the universe that could produce this question is the same universe that is holding you gently right now as you rest, and there is something in that continuity, that unbroken thread from the first stars to this quiet breath you are taking, that carries you naturally and softly toward the deepest sleep of all. And in that stillness, in that profound and tender stillness that surrounds you now, there is a question that has lived quietly at the edge of human thought for decades, a question that astronomers and philosophers and dreamers lying beneath open skies have all asked in their own way, and it is this: if the universe is so vast, so incomprehensibly old and wide and full of the same ingredients that made us, then where is everyone else? This question has a name. It is called the Fermi Paradox, and it was born, as so many important things are, from a simple moment of wondering. In 1950, a physicist named Enrico Fermi sat down to lunch with colleagues in Los Alamos, and somewhere between the conversation and the quiet, he asked something that would echo through science for generations: if the probability of life arising elsewhere is even remotely reasonable, then given the age of the galaxy, given the billions of years that other civilizations would have had to grow and reach and travel and signal, we should have heard something by now, we should have seen something, and yet, the sky is silent, the deep dark between the stars holds nothing we can hear, and that silence, breathed in slowly and gently as you are breathing now, is one of the most extraordinary facts about the universe we have ever noticed. To understand just how strange that silence is, astronomers have tried to calculate how many civilizations might exist in our galaxy alone. There is an equation built precisely for this meditation, named after astronomer Frank Drake, who first wrote it in 1961. A quiet man standing before a chalkboard, trying to turn wonder into numbers. The Drake equation asks us to consider how many stars are born each year in the Milky Way, and of those stars, how many might have planets, and of those planets, how many might be capable of supporting life, and of those, how many might actually develop life, and of the living worlds, how many might eventually give rise to intelligence, and of the intelligent species, how many might develop technology that reaches into space, and finally, the most haunting variable of all, how long such a civilization might survive before it falls silent again. Some astronomers have run these numbers and arrived at the hopeful conclusion that millions of civilizations should exist right now, spread across the galactic spiral like lights in a sleeping city. Others have run the same equation with more conservative guesses and found a number close to 1, just us alone in a galaxy of 400 billion stars, like a single candle burning in an enormous and darkened cathedral. And the radio telescopes that sweep the sky each night, those great curved dishes tilted toward the darkness, listening with extraordinary patience and sensitivity, they have been searching since the early days of SETI, the search for extraterrestrial intelligence, since 1960, when Frank Drake himself pointed a telescope at 2 nearby sun-like stars and listened for 80 hours, hoping for something. Since then, for more than 60 years, we have listened, we have watched, we have scanned millions of frequencies across billions of stars, looking for what scientists call technosignatures, the subtle and beautiful fingerprints of intelligence, a laser pulse, a radio signal with an impossible regularity, the faint warmth of a civilization that has wrapped itself around its own star to harvest every particle of light, and in all that listening, in all that watching across all those decades, the answer has come back in the same form every time: silence, the deep, unbroken silence of a universe that has not yet spoken to us, or perhaps has nothing to say. There was one moment that flickered with possibility, a signal detected in 1977 by astronomer Jerry Ehrman, so striking in its pattern that he circled it on the printout and wrote a single word beside it. Wow! It rose and fell exactly as a signal from deep space should. It had all the qualities that SETI was hoping to find, and then it never came again. No repetition, no confirmation, just a single brief shimmer in the data, and then the silence returned, as vast and soft as it had always been, and we are still not sure what it was. You can let that uncertainty rest in you gently, the way the universe lets its mysteries rest unanswered in the dark between stars. So scientists and philosophers have offered their explanations, their gentle theories for why the cosmic conversation has not yet begun, and each one, when you hold it quietly in the mind, says something different about what we might be. The first and perhaps most sobering possibility is called the Great Filter, the idea that somewhere along the path from simple chemistry to starfaring civilization, there is a barrier so difficult, so improbable, so catastrophically hard to cross, that almost no one makes it through. The unsettling question is whether we have already passed that filter, whether the hard part was behind us, buried in the 4 billion years it took single-celled life to become something complex, or whether the filter still lies ahead of us, waiting in our future like a quiet threshold that every civilization eventually reaches and fails to cross. If the filter is behind us, then we are something astonishing, a rare and precious accident in a universe that almost never produces minds. If the filter is ahead, then the silence of the cosmos might be a kind of warning whispered across the void, and we would do well to carry our fragile civilization with great tenderness and care. Another possibility wraps itself in shadow and mystery. It is called the dark forest theory, and it suggests that the universe is not empty but hidden, that intelligent civilizations have learned, through bitter experience or cold logic, that to reveal yourself is dangerous, that in a universe of finite resources and unknown intentions, the only safe strategy is silence and concealment. In this vision, the galaxy is full of eyes that never blink and mouths that never open, every civilization listening and hiding in equal measure, and the silence we hear is not absence but strategy, not emptiness but fear. It is a darker thought, and you need not hold it tightly. Let it drift past you like a distant cloud as you sink further into rest. There is a gentler possibility too, one that holds something almost touching in its image of us. It is called the zoo hypothesis, and it suggests that advanced civilizations are not absent but watchful, that they observe us the way a patient naturalist observes a creature in its natural habitat, without interference, without contact, allowing us to develop along our own quiet path until some threshold is reached, some marker of readiness, after which the silence would end and the conversation would begin. In this universe, we are not alone but protected, not abandoned but witnessed, cradled in an observation we cannot detect, by minds we cannot yet comprehend. There is something deeply restful in that thought, the idea that to be unseen is not always to be unloved. And yet the possibility that moves most deeply through the chambers of the heart, the one that carries the greatest weight and the greatest beauty in equal measure, is the possibility that we are simply first, that the universe, for all its age and breadth and abundance, has not yet had enough time in the right conditions, in the right chemical richness, in the right stellar stability, to produce many minds, and that we are a pioneer civilization standing at the very beginning of a vast cosmic story that has barely begun to be written. To be first is to carry something extraordinary. It is to be the universe looking at itself for perhaps the first time with eyes capable of understanding what they see. It is to hold in these fragile, temporary bodies, in this brief and precious civilization on a small blue world, the entire weight of consciousness in a galaxy that may otherwise be sleeping. The loneliness of that is real, and you can let yourself feel it softly and without fear, because it is the loneliness of standing at a great edge, looking out over something magnificent and vast that you alone have been given to witness. It is the loneliness of the first light in a dark room, which is also, always, the beginning of illumination. And whether we are rare or simply early, whether the filter lies behind us or before us, whether the galaxy is hidden or watching or genuinely, achingly empty, our existence here, this moment of conscious rest and wonder, is something the universe has gone to extraordinary lengths to produce, 4 billion years of patient chemistry, of stars living and dying to seed the cosmos with the elements of thought, just to arrive at this, a mind that can ask the question and then lie down quietly beneath the stars and wonder at the asking. The silence of the cosmos is not cold when you truly feel it. It is the silence of something waiting, the silence of deep space that has carried starlight across unimaginable distances just to fall softly on a world where someone, tonight, is lying still and breathing slowly and letting the question rest unanswered and beautiful in the dark, and that same darkness, that same patient and enveloping quiet, has been the backdrop of every great discovery humanity has ever made, whispering that some of the most profound truths reveal themselves not in noise, but in the gentle surrender to stillness, which carries you now, like starlight traveling home, into the next soft mystery waiting just beyond the edge of waking.